Hello friends, in the last video we have learned how to apply Newton's first law in case of one-dimensional equilibrium. In that case basically you write equation of motion or equation of equilibrium either along the x-axis or along the y-axis. Now in this session we will see how to apply Newton's first law when you have a two-dimensional equilibrium. We will illustrate this using an example. So this problem says a car engine with weight W hangs from a chain that is linked at ring O to two other chains, one fastened to the ceiling and other to the wall. So we have a car engine here and the weight of this engine is given, that is W. Now this engine is hung from a chain. So this is one chain. So one end of this chain is attached to the engine and other end of this chain is attached to a ring. And this ring is also supported by two other chains, this one and this one. One chain is inclined and other chain is horizontal. Now the question further says, find the expression for tension in each of the three chains in terms of W. So the tension is these three chains are different. In this chain tension value is T1, in this chain tension value is T2 and in this chain tension is T3. So we have to find T1, T2, T3 in terms of W. So in this problem what are unknown, that is what are target variable. So target variables are, so we have target variables T1, T2 and T3. So there are three target variables, three unknowns in this equation or in this problem. Furthermore, the problem says the weight of the ring and the chain are negligible compared with the weight of the engine. So we have to neglect the weight of engine, not the engine, weight of chain and the ring. So assume, so this is the assumption we have to make in this case and that is given in the problem. That is weight of chain and ring is almost 0. So let's call this as a 0. Now how will you solve this problem? So in this case you see there are three unknowns. And unknowns are T1, T2 and T3. So if you want to solve this, you require three equations. So you require three equations. And of course these equation has to be independent. So basically you require three independent equations. Now if you remember, if you write equation for one object, you can write only two equations. If you consider a planar object, then you can write only two equations. One along the x-axis, another along the y-axis. So you have to consider more objects because if you consider one object only, you can write only two equations, but the number of unknowns are three. So we have to consider in this case more than one object, at least two objects. So we'll consider two objects and we will write equations. So let us consider two objects. And what will be these two objects? One will be engine and another will be ring. So these two objects will be engine and ring. So let us try to draw the free body diagram. So what I am saying, we have to consider one engine, one object, another object is this ring, and then we have to draw the free body diagram and then we can write equation of equilibrium and then we can solve. So what are the forces that is acting on this engine? One force is acting, that is weight. Another force that this chain is trying to pull this engine in the upward direction, that is force T1. So let us write free body diagram or draw free body diagram for engine. So this point denotes engine, and this weight is acting in the downward direction. Let's say mass of this engine is m. Basically weight of the engine is given, so simply we can write w. So that is acting in the downward direction, and the tension force is acting in the upward direction, and this tension force is T1. So this is the free body diagram of engine. Now similarly we can draw free body diagram of or for ring. So let us draw free body diagram for ring. So once again we can show ring as a point mass. So this point denotes ring, and this ring is a massless ring. So there is no weight acting. What are the forces acting? One force is tension, that is acting in the downward direction, and this tension will be T1 because this is a massless chain. So each point of this chain will have same tension, and the value of this tension will be T1, and that's why on this ring in the downward direction a tension force will be acting, and that magnitude will be T1. Similarly, this chain will apply a force in this direction, and this tension will be T2. Now assume that this chain remains horizontal, and that's why we can show tension force in a horizontal direction. Another force that will come from this chain, and that has a magnitude of T3. So these are the three forces that is acting on this ring. Now let us call this as x-axis and this as y-axis. So this is the positive direction of x-axis, and this is the positive direction of y-axis. Now if you see, this angle is 60 degree. This means this angle is how much? This angle is also 60 degree. So we can show this angle. This angle is theta, and theta is equals to 60 degree. Now these two objects are in equilibrium. So we can write equilibrium equations, that is we can apply Newton's first law. So let us apply Newton's first law in this case for these two objects. So first we can consider equilibrium of engine. So equilibrium of engine. So now what are the forces that is acting? In this case there is no horizontal force. So if I consider horizontal force component of all horizontal forces summation 0, this does not give anything because in the horizontal direction in this case nothing is acting. Now if I consider summation of all the forces in the y direction is equals to 0, this will give me vertical direction I have a force T1, and the downward direction, this is a upward direction, that's why we have taken positive. Now downward direction we have a force W, and that is a negative because this is in the downward direction. So this gives me tension T1 is equals to W. So we calculated one part, that is T1 is equals to W. Now next what we can do is we can consider equilibrium of ring. So let us consider equilibrium of ring. So what are the equation we can write? If I write summation of fx is equals to 0, this will give me forces in the x direction. So what are the forces that is acting in the x direction? This force, that is T3, has two components. One component along this axis and other component along this axis. So in this direction you will have T3 cos theta, and along this axis, that is y-axis, you will have T3 sin theta, where theta is equals to 60 degree. Now so what are the forces that is acting in the x direction? T3 cos theta, that is positive, and T2, that is negative. So let us write in x direction T3 cos theta minus T2 is equals to 0. So this is the equation in the x direction. Similarly I can write equation in the y direction. So bidirection I can write summation of Fy is equals to 0. So this will give me what are the forces that is acting in the bidirection. T3 sine theta, that is positive, and T1, that is negative. So I can write T3 sine theta minus T1 is equals to 0. So let us write this. T3 sine theta minus T1 is equals to 0. So now I know T1, so I can calculate T3. So from, let's call this is equation 1, this is equation 2. So from 2 I can write T3 is equals to T1 divided by sine theta. And theta is equals to 60 degree. So this is simply T1 divided by sine 60 degree. And sine 60 degree is root 3 by 2. So this will be T1 divided by root 3 by 2. So this is 1.2 W. So we calculated T3, that is nothing but 1.2 W. Finally, I can use equation 1. So if I use equation 1, I can calculate T2. So T2 is how much? T2 is simply T3 cos theta. And now I know T3. T3 is basically T1 divided by sine theta. So T1 divided by sine theta and then multiply by the cos theta. And in this case, I know cos theta, basically theta equals to 60 degree and T1 is equals to W. So we can write W cos 60 degree and this divided by W. So not W, simply sine 60 degree. Now if you plug all this value, you can find T2 is equals to 0.58 W. So this is value of T2. So we have solved for T1, T2 and T3. So T1 is equals to W. So we can write here T1 is equals to W and T2 is equals to 0.58 W. And T3 is equals to 1.2 W. I can show all this in a free body diagram. You remember, if you draw a free body diagram for ring, you have T1 in the downward direction, which is equals to W. You have T2 that is in the horizontal direction, and this is nothing but 0.58 W. And then you have T3 at an angle of 60 degree, this is 1.2 W. So a few important points in this case, the maximum value of tension occurs in chain 3, that is 1.2 W. So if there is a chance of breaking of any chain, then chain number 3 will break first because it has maximum tension. And also the tension T3 is greater than W, that is 1.2 W. So little bit greater than 1.2, little bit greater than W. This is because this T3 is balancing T1 as well as T2 both. And that's why this is greater than W, because it also has to take care of T2. So in this video we learned how to calculate or how to write equation in case of two-dimensional object. You have to basically see how many unknown you have, and then correspondingly you have to think of how many equation you are going to write. For that purpose you have to divide your system into different components and you have to write equation or equilibrium equation for each component, and subsequently you have to solve the equation to get the unknown or target values. I hope you like this video. If you like, please share with your friends, like and subscribe. I will see you in the next video. Thank you for the time being.